Here's your last lesson, Math 1B. It's on graphing linear systems of equations. Let's just jump right in. This is the part where you guys have two equations to deal with, and their point of intersection is going to be the solution. So your solution is going to be an xy coordinate, something like this. So let's not forget that. There's going to be a number here, there's going to be a number there, and it's going to represent the point of intersection between these two lines. So first thing I'm going to do is get y by itself, because we're really tied to this y equals mx plus b template for graphing lines. The m is the rise over run, the b is the place where it crosses the y-axis. So when you see this equation y equals blank x plus 2, you're thinking 1 is the implied x coefficient, and really you can call 1 1 over 1 to give it that rise over run flavor to it. So this plus 2, that's the b value. That means it's going to cross the y-axis. The y-axis 2 units above the origin. And this 1 over 1 means it's going to rise 1, run 1 each time. Up 1, over 1, up 1, over 1. Or down 1, left 1, down 1, left 1. So if I weren't able to get a great ruler, straight edge, whatever you want to call it, I could at least plot these points and connect them freehand that way. So at least I'm crossing over all the points that were plotted. Not the straightest line, but you get the idea. Here we got to divide by 3 in order to create this same template situation for a line. Now I'm going to put a 1 in front of the x, so there's no confusion about what does x divided by 3 mean. It's 1/3 x. Now there wasn't a b value listed for us, but if that's the case, all you guys say is, all right, there was none given to me. That means 0 is going to be my first plotted point. And then this is going to tell me to go up 1, right 3. 3, up 1, right 3. Or down 1, left 3. Found our point of intersection. Down 1, left 3. I'm going to graph the line though. And our point of intersection is this dot right here, which is left 1, 2, 3. The x value is -3. The y value is down 1. There's my solution. I'm going to skip example 2 because I didn't give you guys any on the homework that look like that, so we'll just move right on to 3. So you've got two equations. Neither of which match the y equals mx plus b template that we need it to. So for the first one, I would subtract 2x from both sides. And you got 3y equals, I'm going to write -2x first, because it kind of looks like mx if I write -2x first, plus 12. Then divide all parts by 3. Y is -2/3 x plus 4. All right, so that right there means we're going to start 4 units above the origin on the y-axis. 1, 2, 3, 4. Notice I'm never plotting on the x-axis to start with. It's always the y-axis. Then it's going to go down 2 from the point I plotted. 1, 2, right 3. So down 2, right 1, 2, 3. Down 2, right 1, 2, 3. Up 2, left 1, 2, 3. All right, the second line, I actually got an easy fix for this. Instead of moving the x to the right and then having to deal with the -y, what if I were to just flip the y and the 4? I'll show you what I mean. Let's just say plus y here, okay? And then plus y on the right-hand side. So I effectively got rid of the y on the left-hand side, which is normally not a great thing to do. But if I do that, and then I take minus 4 from the right and minus 4 from the left, I got y by itself. It's inverted. It's in the other part of the equation than you're normally used to seeing it. So 2x minus 4 is equal to y. Or y equals 2x minus 4 using, it's called the symmetric property. I talked about it in the last video. All right. Now, if that was totally uncomfortable for you, this was the other way of doing it. You could have subtracted 2x. And then divided by, I'm going to put a 1 there. By negative 1. You'll still get 2x minus 4. I don't know. Some people they tend to drop their negatives more than they should, and this can kind of help avoid that. So, take it or leave it. This one starts 4 below the origin on the on the y-axis. And then you're going to go, I'm going to make this 2 over 1 so that we have a pretty clear picture of who's the rise and who's the run. So up 2, right 1. Up 2, right 1. Up 2, right 1. Up 2, right 1. Or down 2, left 1. The point of intersection is the x-coordinate 1, 2, 3 and the y-coordinate 2. Keep in mind, too, that students oftentimes will get the rise over run confused with the x, y. They'll try to reverse it. So you got to really separate those two concepts within your brain. It's like you want to say up 2, right 3, and make it 2, 3, but it's 3, 2. That's the ordered pair coordinate. So number 4. Oh. Number 4 is a bit of a special case. Y equals 4, x equals negative 3. If you've forgotten, we have what are called horizontal and vertical lines. Horizontal lines travel left to right with pretty much no slope. Vertical lines are basically like this. Pretty much, it's like parallel to the y-axis here. So when you see y equals 3, it's this idea that it's going to cross the y-axis at 1, 2, 3, y equals 4 means it's going to cross the y-axis at 1, 2, 3, 4. And it's going to be horizontal. So it's going to be, the y value is going to be for here, and there, and pretty much everywhere on that line. Now, x equals negative 3 means it's going to cross the x-axis 3 units left of the origin, which means it's going to be the x value is negative 3 here, and there, and everywhere. So, this was x equals negative 3. This is y equals 4. The place where it intersects is left 3, up 4. Negative 3, 4. Which makes sense. X equals negative 3, y equals 4. We probably could have given that answer without even graphing it, yeah? All right. You have 5 problems where you got to graph this stuff tonight. It's due May 8th at about 4 p.m. It's the last assignment for remote learning, so I will let you guys know once you get that assignment in what your grade is for the semester. So I will be in touch with you guys then. See ya.